In this lesson, we are going to discuss some important points about SHM. In SHM, F is equal to minus kx and A acceleration is equal to minus omega square x. Therefore, both the fx graph and the ax graph are straight lines passing through the origin with negative slope. So here the slope is minus k. Here the slope is minus omega square. So both the fx graph and the ax graph are straight lines with negative slope. Any function of time is simple harmonic if d2x by dt square is proportional to minus of x. So any function of t will oscillate simple harmonically if d2x by dt square is proportional to minus x. All sine and cos functions of time are simple harmonic in nature. That is x equal to a sine omega t plus minus phi naught and x equal to a cos omega t plus minus phi naught. Instead of x we can have y. Okay, it makes no difference. So any sine or cos function of time oscillates simple harmonically. Now if we take SHM as x equal to a cos omega t plus phi naught, then this x varies from minus a to plus a. So we are taking x equal to a cos omega t plus phi naught. We can take it as x equal to a sin omega t plus phi naught also, no problem. But let us take it as a cos omega t plus phi naught. X varies from minus a to plus a. Velocity we get by differentiating this. So velocity is dx by dt. So if we differentiate this, cos will become minus sine and 1 omega will come out. So you'll get minus omega a sine omega t plus phi naught. Therefore, this velocity varies from minus omega a to plus omega a. So v is dx by dt equal to minus omega a sine omega t plus phi naught, and velocity varies from minus omega a to plus omega a. Acceleration is dv by dt. So we'll differentiate this again. Sine will become cos and one more omega will come out. So we'll get minus omega square a cos omega t plus phi naught. And this acceleration varies from minus omega square a to plus omega square a. So acceleration varies from minus omega square a to plus omega square a. Now if you look at the equation of kinetic energy with time, kinetic energy is given by half mv square. So this kinetic energy will be half m, this one square, omega square a square, sine square omega t plus phi naught. And this kinetic energy therefore varies from 0 to half m omega square a square. At the extreme position, kinetic energy is 0. At the mean position, kinetic energy is maximum. So these equations are important. We have to memorize them. Okay. Now, if you look at potential energy with time, potential energy is given by half kx square. Okay, and in SHM, k is m omega square. Omega is defined as root over k by m. So therefore, this potential energy, which is half kx square, becomes half m omega square a square cos square omega t plus phi naught. The minimum value of this is again 0, or we take it to be 0. So minimum value of this will be 0, and the maximum value will be half m omega square a square. The value is 0 at the mean position and maximum at the extreme position. Now if you look at total energy is k plus u, and this will turn out to be a constant, and that will be half m omega square a square. So total energy in SHM is constant. If you look at the relationship between velocity and displacement, v is equal to, we can write minus omega, or we can just write omega root over a square minus x square. Acceleration is minus omega square x. F equal to minus kx. Kinetic energy is equal to half mv square, so half m omega square a square minus x square. Potential energy is half m omega square x square, and total energy, which I written earlier also, is a constant half m omega square a square equal to constant.